Welcome, this is lesson 7.6, graphing linear inequalities, and our goal today is to be able to solve a system of linear inequalities. Okay? To basically understand this, we're first going to review our steps with graphing each line. So, when we have a solid line, it's when it's less than or equal to or greater than or equal to. We have a dotted line if it's greater than or less than. And then to shade below, we know if it's y is greater or y is greater than or equal to, we shade above. If it's y is less than or y is less than or equal to, we shade below. We can also use a test point. That is always possible to use a test point to kind of check to see where you would shade that. Okay? Now, with the system of inequalities, we're actually going to have two inequalities in the same problem. So there's going to be two shadings, and it's where it is double shaded or where the shadings overlap each other that is your final answer. So let's take a look at a couple examples of this to kind of see what's happening. So if you look at number 1 here, we have y is less than 2x minus 3, and y is greater than or equal to negative x plus 2. So I'm going to graph this first line on the grid so that we can actually see what's happening. So this first line I'm going to do in red. This line's going to start at negative 3, and then it's going to go up 2 and over 1, and that's going to continue all the way up the graph. You could also go down 2 and left 1, and that'll create your line. The shading for this line, because it's y is less than, would be below this line. So below this line would be down in this region here. So I'm just going to put a little mark down here so I know that I want to be under the line. It would actually be all the way down under, but I'm going to have a double shading here because I have a second line. Now I'm going to do this second line in blue. This line is going to start at positive 2 because the y-intercept is positive 2. The slope is negative 1, which means I come down 1 over 1 all the way down my graph. And you can see these two lines are definitely going to intersect each other. And that line's solid. Oh, my first line should have been dotted. Fix that here. Now, for this second line, which is in blue, I want to shade above that line, which is here. So what I'm looking for is where do those two shadings overlap each other? Well, if I am above the blue line and below the red line, I'm going to put my final answer in green. It's actually going to be this section here. So your final answer is all the points that would be double shaded in there. And you can check that by plugging in any of those points and see that it works in both system of inequalities. Now, if you look at number 2, it's just a new problem, same concept. We're going to be graphing the two lines and seeing where the shadings overlap each other. So if you look at this first line, again, I'll do it in red. It starts at negative 2. So I'd start at negative 2. The slope is 1, up 1 over 1. And that's a dotted line. I can actually start drawing my dotted line here. And because it's y is greater than, you want to shade above this line. So I'm just going to mark above this line. My second line I'm going to do in blue. That line starts at 1, and then it goes up 2 over 1, up 2 over 1, or down 2, left 1, down 2, left 1, up 2, left 1. That's also dotted. And I want to be below that line. So if I'm below that line, I'm here. And where those two shadings overlap is where the red and the blue come together. Will be that section there. Okay? So again, you graph each inequality on its own, and you find where the two sets will actually overlap each other. And where they overlap each other, that's your final answer. Now, is it possible to just have vertical and horizontal lines? Sure. Remember, going all the way back, x is just a vertical line, and y would mean it's a horizontal line. So if it's just x equals, it's a vertical line. If it's just y equals, it's a horizontal line. So if x is less than 2, we go over to 2 on the x-axis, and we draw our vertical line, which is dotted. X is less than, so we would shade to the left. So we know that's over here. Y is greater than -1. So -1 on the y-axis would be here. So I'm going to draw my line, which is a horizontal line. And if I want to be above that line, the two shadings will come together in this top section here, because the two lines come together here, and that's my final answer. Because that would be the double shading. Whenever you graph each line, again, doesn't matter if they're horizontal and vertical lines or diagonal lines. You graph the lines, you do your shading, and where it is double shaded or where the shadings overlap, that is your final answer. Okay? We'll see one more that kind of has a mixture. This one has a vertical line and a diagonal line, which is no problem. You graph each line. So when it's x, that's going to be a vertical line. So this is x is less than 5. Draw my vertical line down through 5. X is less than would be to this side. Y is less than or equal to x plus 2. Be up at 2. Slope is 1. Up 1 over 1, up 1 over 1. That's a solid line. Now for that line, I want to be shading below that line, which is down here. So this will cover a lot of this graph, or most of this graph on this grid. But in reality, we're going to cover a ton of points anyway. There's an infinite amount of solutions, because these lines continue on forever. It's just a matter of how big your graph is, how large your answer looks. But this is our double shaded region, or the overlap. So that's our final answer. So when you're solving a system of inequalities, graph each line on its own, shade each line, and where the two shadings overlap, that is your final answer.